Today we're doing section 10.3 part 2. We're doing multiplying and simplifying radical expressions. And we're going to do objectives 1 and 2, that is use the product rule to multiply radicals and then simplify. So let's look at the product rule. The product rule says if you have the nth root of a and the nth root of b and there are real numbers, then the nth root of a times the nth root of b equals the nth root of ab. So you can multiply underneath square roots. That's basically what this is saying. And you can go in reverse. If you have a number, the nth root of ab, you can split it up into factors, nth root of a times the nth root of b. And we're going to do both today. So let's look at example 4. In example 4, we're going to start splitting them up into factors, actually. We're going to rewrite this, and we sort of did some of this in part 1. It's going to get a little bit more complicated today, but it's very similar. We're going to rewrite this as the square root of things we can take the square root of, perfect square numbers. And perfect square numbers are numbers that are even. That's because we can divide by 2. That's why they're perfect square powers, actually powers that are even. So let's look at rewriting this example 4 into a bunch of different factors, and we're always going to take one less. So if I want to take the square root of x to the 5th, we're going to take one less than that and make it even. So x to the 4th, square root of x to the 4th, times one more square root of x, because x to the 4th times x makes x to the 5th. And we're going to do it with the y too. Take one away, so that'd be square root of y to the 12th times another square root of y. And 12 and 1 make 13 y's, so that'd be the same as square root of y to the 13th. And we're going to do the same thing with the z's. Square root of z to the 6th times the square root of z. Now, anything we can take the square root of, which means the even power ones we can take the square root of, we're going to do that, and we'll be left with the odd power ones, which are just x, y, and z in this problem. So, when you take the square root of an even power, you divide by 2, because your root out here is a 2. So, we don't write that 2 normally, but that's our root. So that's what we divide by, the power by, so it's going to be x squared. And we can't do square root of x, so that's just going to stay a square root of x. And we divide the 12 by 2, and we get times y to the 6th. And we can't do the square root of y, so it's going to stay as a square root of y. And times the power on the z is 6, so we're going to divide that by 2 and get z to the 3rd. And we got a square root of z. The last thing you do is take anything without a square root, anything that you've already taken the square root of, that goes out front. So we've got x squared, y to the 6th, z to the 3rd, and anything that's underneath the square root gets shoved together under one square root. So x, y, and z. Pause here, try your checkpoint. When you come back, I'll give you the answer. Checkpoint 4. You should have gotten x to the 4th, y to the 5th, z, square root of x, y, and z. Oh, by the way, this right here, if you can't read it, that's a 3rd power. It should be z to the 3rd. Should have told you that before you did the checkpoint, but that's what it is. Let's turn the page, go to example 5. Example 5 says simplify cube root of 32 x to the 8th y to the 16th. So now we're doing cube root. It works just the same, except for we now have to have perfect cubes instead of perfect squares. And perfect cubes, in terms of exponents, means exponents that can be divided by 3. And in terms of the 32, the number in front, we got to go back to our perfect cube numbers. The first perfect cube number is 8, because the cube root of 8 is 2. And 8 goes into 32. It goes in 4 times. So I'm going to rewrite this as factors. whoops, let me get my pen out, as cube root of 8 times the cube root of 4, because 8 times 4 is 32. Let me rewrite that so it looks right. Cube root of 8 times the cube root of 4. There we go. And then we're going to start doing our variables. X to the 8th can be written as, I'm going to write it as x to the 6th times x squared, because 6 plus 2 is still 8. But I want to write it as x to the 6th because that power is a perfect cube if it could be divided by 3. So I'm going to write the cube root of x to the 6th times the cube root of x squared. And we're going to do the same thing with y, except for we're going to write y as y to the 15th, because 15 can be divided by 3 and another y. So the cube root of y to the 15th times the cube root of y. Now, we're going to take the cube root of anything we can take the cube root of for this step. The cube root of 8 is 2, and we're timesing that by the cube root of 4. We can't take the cube root of 4. The cube root of x to the 6th, we're going to divide 6 by 3, and we're going to get x squared, times the cube root of x squared, because we can't take the cube root of that, times the cube root of y to the 15th. We're going to divide that 15 by 3. We're going to get y, oops, y to the 5th. And we're going to get a cube root of y. And in our last step, we just take anything that has already had the cube root taken out of, so our 2, our x squared, our y to the 5th, put them in front. 2x squared y to the 5th. And anything that we can't take the cube root of, put it underneath one big giant cube root, which is 4x squared and a y. So 2x squared y to the 5th, cube root of 4x squared y. And I know these two things look funky next to each other, the 5 and the cube, but that's the way you would write it. If you really wanted to, you could separate them with a parenthesis. There's nothing wrong with that, but you don't have to. So pause here, try your checkpoint. When you come back, I'll give you the answer. The answer to checkpoint 5 is 2x squared y to the 4th, cube root of 5 x to the 4th, y squared, cube root of the whole thing. Let's look at example 6. Now we've done square roots, we've done cube roots. Now we're going to do fifth root. And it works the same with all the roots. You still got to know the perfect root numbers. So we could do a fourth root, we could do a sixth root, or a seventh root. But in this one, we're doing the fifth root. Let's move it up. And we got the fifth root of 64 to deal with. So we need a perfect fifth root, or perfect fifth power, I guess. And 2 to the fifth power is 32. So, and 32 times 2 is 64. So 32 is a perfect fifth root. So we can write this as the fifth root of 32 times the fifth root of 2. And we've got this fifth root of x cubed. X cubed isn't big enough for 5 to go into evenly, so we're just going to keep it as the fifth root of x cubed. Now y to the 7th, we can get a 5 into there. We can get 5 into the y to the 5th, so we're going to write a fifth root, a fifth root of y to the 5th times what's left over. We got 2 left over, because 5 and 2 is 7. So that makes our y to the 7th. And we got to do the same thing with z. Well, we can get it up to 25 for the z, because 25 divided by 5 will work. It's 5. So we're going to take the fifth root of z to the 25, and that leaves the fifth root of z to the 4 left, because 25 and 4 make 29. And I know this is long, but that's the way it is. We're going to take the fifth root of whatever we can take the fifth root of. Fifth root of 32 is 2. Can't take the fifth root of 2, so we're going to write that as the fifth root of 2 times the fifth root of 2. Times the fifth root of x cubed, can't do, so times the fifth root of x cubed. Now, the fifth root of y to the fifth, that's just y. We can do that. So times y. Times the fifth root of y squared, we can't do that. The fifth root of z to the 25th, we're going to take the 25 and divide by 5 and get 5, so that's going to be z to the 5th times the fifth root of z to the 4th. So again, just like in our cube root and our square root, anything that we took the fifth root of, we're going to put in front. So that's our 2, our y, and our z to the 5th. 2y z to the 5th. And then anything else is going to go underneath one big fifth root symbol. So we got the fifth root of, and I'm going to make it bigger, 2y squared. Oops, I missed my x. Sorry. Well, I can make that an x. 2x cubed y squared z to the 4th. That's all under the fifth root there. And that's our answer. Pause here, try your checkpoint. Okay, checkpoint 6 answer is 2x squared z fifth root of x squared y squared z cubed. That's the answer for checkpoint 6. Let's go into multiplying and then simplifying. That's the next example. And our rule says underneath a radical, if we have two things multiplied, we can actually multiply them. So we can take 15 times 3 and get the same square root of 45. Now we can simplify that square root, because 45 is 9 times 5. So we're going to say, all right, this is the square root of 9 times the square root of 5, and the square root of 9 is 3. So we got 3 times the square root of 5. That's our answer for A. For B, you've got these numbers in front, 7 and 5. You can multiply those numbers in front, and they will just be regular numbers, no root over them. 7 times 5, we know, is 35. And then we get the cube root, and we can multiply the 6 times the 4. So that's 24. 35 times the cube root of 20. I put 25, I don't know why. 35 times the cube root of 24. Jeez, now I'm saying 25. And 24, we're going to have to break down. Perfect cube that goes into 24 is 8. 8 times 3 makes 24. So we've got 35 times the cube root of 8 times the cube root of 3. 8 times 3 makes 24. So now we can take the cube root of 8. It's 2. So we get 35 times 2 times the cube root of 3. Well, 35 times 2 is 70. So we get 70 times the cube root of 3. And that's my answer. Let's look at C. We're going to multiply the 8. Okay, they're both fourth root, and so you can multiply them. So we're going to get the fourth root of 64. 8 times 8 is 64. When we take x cubed times x to the 5th, we're going to add the exponents. So that's x to the 8th, y to the 5th. So we got the fourth root of 64, x to the 8th, y to the 5th. We're going to break down 64 into perfect fourth roots. 2 to the 4th is 16. And 16 times 4 goes into 64. So I can break 64 into 16 times 4, and 16 is a perfect fourth root. So I got the fourth root of 16 times the fourth root of 4. Now we're looking at 4. See how many 4's go into the powers. To take the fourth root of a power again, we're going to see how we're going to have 4 divide evenly to that power. And 8 actually works, so we can just leave that as the fourth root of 8. Oh, x to the 8th, sorry. Oops, now I screwed it up. I can't erase it. I'm going to have to scratch this out. Or just make it x to the 8th. Times the fourth root of y to the 4th times the fourth root of y, because y to the 4th times y makes y to the 5th. Alright, so the number, fourth root of 16, we can do that. That is just 2. And then times the fourth root of 4, we can't do that. The fourth root of x to the 8th, we're going to take the 8 and divide by 4. That's going to give us x squared. The fourth root of y to the 4th, that's just going to give us y. So times y. And the fourth root of y we can't do, so that's the fourth root of y. Now, anything we took the fourth root of, sorry, I was going to say square root there, we're going to put that out front. So that's the 2, the x squared, and the y, and that's going to go out front. 2x squared y. And we're going to multiply that by whatever's left under the big fourth root, which is 4y. Pause here, try your checkpoints, and then I will give you the answers. The answer to checkpoint 7a is 2 times the square root of 3. B is 100 times the cube root of 4. And C is 2x squared y times the fourth root of 4. That's all for this section. I will see you in class.